Good morning, folks. Welcome to the telco workshop. I'm Samitra Bojan. I'm one of the lead for the telco project, and I also work for AT&T. I want to quickly, introduce the team. We have Mike Moore here, is the sub-project lead, openEDGE sub-project lead. Jeff Catlin, I want to say thank you to you for being the IC rep the last 2 years. Appreciate all the work. And Craig White, he's the new IC rep. So we do have a good lineup of speakers. So with that, I'm going to introduce the first speaker, Pier Luigi from ONF. Welcome, thank you.
Thank you. Hey, good morning. I'm Pier Luigi Ventre from Open Networking Foundation. I work at ONF as a member of technical staff. Today's talk is about how ONF is driving transformation in telco infrastructure through adoption of OCP hardware and software. First, 2 slides about ONF. What is ONF? ONF is an operator-led consortium. Operators are facing challenging demand coming from the evolution of IP networks, and they are collaborating under ONF umbrella to solve a common problem, providing, I would say, common tools, cloud-like building blocks in order to get cloud-like economics and agility. What they usually do under ONF umbrella is to, work on common use case to jointly pursue, and then they commit for the deployments. ONF engineering team is an independent engineering team. I think right now we are 20 or 30 people. We don't have any legacy to protect, and we are committed for this mission. Here you can see how our community is structured. We have at the top level the operator partner and the vendor partners, but our community counts more than 160 members. And we have in our community system integrator, ODM, vendors, each one having a proper role in this community. Our mission is to transform operator networks to bring CAPEX and OPEX efficiency and innovative service. How we do this, we leverage 3 main principles, which is disaggregation, white box hardware, open source software, and then we apply SDN, FV, and cloudification principle with a special focus on access and edge. Our old project fall under the umbrella of Core Platform, which stands for Central Office Re-architect as Data Center. Core is our open source software stack for open disaggregated access and edge. The high-level idea of Core is very simple. Operators have a large variety of customers, which can be mobile, enterprise services, or residential service. They are served by this central office, but each type of customer is actually served by a different chain of equipment. There are different system tools. The result is that these central offices are very complex. There are huge expenses in terms of CAPEX and OPEX. The idea of Core is very simple. Keep the customer, but then move the infrastructure and the services to off-the-shelf hardware, and then apply the same principle that I said before, SDN, NFV, and cloud principle, open source software and disaggregated hardware. And here you can see how the single pieces, which are actually our project, and in this big picture. So let's get started with Volta, OLT disaggregation. Here you can see a traditional OLT from a vendor. So there are the PON MAC blades, which are interconnected to a backup plane to the compute blades where the software run. Then, of course, there is a management system for this box, and you need to support a number of protocols in these boxes. The SDNization starts taking these PON MAC blades and consider just as a pixel box device, like a white box switch, with the difference that they don't have only Ethernet ports, but they have also optical ports, which leads to the optical distribution network and then to the end users. Then on top of this, there is Volta. Volta means virtual OLT hardware abstraction. It is a software that sits on top of this device and manages this device. It's meant to be an abstraction layer. what is his role? Is to manage all the optical part and then present each OLT device as a pseudo Ethernet switch at the northbound. And then on top there is an SDN controller, which doesn't care how the OLT device works, but just care how to program an Ethernet switch. And then Volta will take care of all the differences and will take care of the optical part. So the SDN controller doesn't see any message flowing between the ONIE and the OLT. And here you can see how we are collaborating with the OCP project. So the OLT device run OCP accepted software like ONL and ONIE. Operators are submitting a specification to the OCP project. AT&T has one for XGS-PON. Deutsche Telekom recently submitted one for the GPON boxes. And then there is the ONF community that is building this software to control this device. Then there is SEBA, SDN Enabled Broadband Access, which is the system that we are building around this. Let's keep Volta and the OLT and then connect the aggregation switch to this OLT device. Also the switch, a white box switch, OCP accepted. This switch aggregate the traffic and send back to a BNG, and then, of course, they take the traffic coming to BNG and send back to the OLT. Big news is that we have recently realized also disaggregation of BNG functionality. We presented 2 weeks ago at NF Connect a POC with the aggregation switch and the OLT performing the functionality of a BNG. Then there are servers connected to the switch where our software run, which is Volta, ONOS, and then there is the network edge mediator, which orchestrates all the entire pod. The pod is a fully containerized solution. We have around 40 to 50 containers, all orchestrated by Kubernetes. On top of the network edge mediator, there are the OSS, BSS, because the role of NEM is to provide visibility of the entire pod in terms of FCAPS capability. And of course, it offers a northbound where the operator can attach their OSS and BSS. Then, if you take this switch and consider a lift device, you can expand this switch to be an entire fabric. And here there is Trellis. Trellis is our leading open source leaf-spine fabric. It is open source like our software. This means that you can take the code, customize it, integrate in your solution. We leverage an SDN controller, which means centralized control, management, simplification, optimization of your network. And of course, we use white box hardware. In this case, OCP accepted. Trellis support, of course, server connected to it, where you can run your computing workload, your VNF, you can attach upstream router, and we support different type of access device. And you have the choice of different configuration, which can be a single leaf, like in SEBA, or a 2x2, a 2x4. And if you need, you can have the fabric deeper in your network, like in this case, where you have basically the central office and the filed office near to your customer. Trellis supports different type of chipset and hardware coming from different vendors, like EdgeCore, Delta, Inventec, QCT, Stordis, and so on. And we support also P4 capable device, which help us to build new feature. For example, the BNG functionality has been realized in SEBA leveraging a P4 capable device. Then there is a Stratum. Stratum is the next gen TIN-OS. Next gen TIN-OS. What are the main building blocks of Stratum? There is a pipeline definition, which is a P4 program, a number of control interface which fall under the umbrella of P4 runtime. We do configuration and streaming telemetry through GNMI. Then there are a number of microservices under the umbrella of GNOI. As I said, Stratum is a TIN-OS, does not provide the full functionality of a NOS, but you can build on top your preferred approach, which can be a local NOS or a classic SDN control plane. Stratum implements all these interface, and it is just a user space running in open networking Linux. And there is support for cloud native chain. This means all the operation can be fully automated. You can deploy it inside a Docker container, and this means that you can deploy it together with Kubernetes in your platform. We support for Stratum different type of device. Regarding the flexible pipeline, we support Tofino chipset. A recent news is that we are supporting also the fixed pipeline, in particular the Broadcom Tomahawk chipset. And as you may heard, recently Stratum now is open source, and different vendors are already ported the device to Stratum, which are, for example, EdgeCore, Delta, Inventec, StarDisk, QCT, and so on. Then there are other projects which are ODTN and COMAC. ODTN want to build disaggregated transport networks in a multi-vendor fashion, and wants to use OpenAPI to control the optical networks. In particular, we use TAPI for OLS and NetConf for the ROADM. Then there is COMAC, which is Convergence Multi-Access Core Network, which wants to build a playground enabling the convergence of access and core networks. With these slides, I want to bring to your attention that actually the solutions that we are building together are having a real impact. As you may heard now, Trellis and ONOS are serving real customers in Comcast. There are small deployments with SEBA, but some operators committed for significant trials. For ODTN, we have lab trials. Stratum, the initial code was provided by Google that runs Stratum in its production network. And regarding COMAC and HOMEC, HOMEC is Open Mobile Evolved Core, is an open source APC. Recently, Sprint and T-Mobile Poland have announced deployment. The second part of the presentation is to provide some lessons learned from the deployment experience of our open source project. This because when you start playing with a project in the initial phase, most of the issue maybe you will not see this issue. But when you start playing deployments or in production at scale, you will start to see new issues that maybe you never seen during the first phase. And I think it can be useful for the audience learn what we learn with our deployments. First lesson: everything is affected, and hardware and software issue can occur at any time and sometimes all together, making, I would say, the troubleshooting an art. In this case, we had that ONOS and Trellis were overwhelming the switches when there are a lot of flows that needs to be programmed. In particular, we found that high CPU usage in the switches, buffer overflow in the OpenFlow agent, which disconnect from ONOS. And this situation can be even worse when ONOS starts collecting OpenFlow stats from the switch. So in order to overcome this issue, we came out with a new stats improvement, a new algorithm, which posts the stats collection when an intensive programming period is happening. We eliminate the stats update on tables that doesn't even support counter, and we introduce an accumulator in the ONOS driver in order to accumulate flows coming from different applications and reduce the number of transactions requested to the device. And of course, some improvements were needed on the switch side. The second incident that we have was even more curious. We had deployments running for more than 1 month. And then we start seeing a warning in ONOS saying that there was an IP that was flapping between 2 MAC addresses. And the second MAC address actually was completely fake, was not existing in the network. Also, we found that the packet-in have a wrong input port, and there were deserialization errors in ONOS, like truncating packets. At the beginning, we were thinking that there was a software issue, but at the end, it was an unlucky switch unit that seems had a problem. If we reboot the switch, actually, we were able to solve the issue on the switch side, but this duplicate IP warning was continuing in ONOS. So at the end, we found also a bug in ONOS. In the third incident that we had was we had ONOS. The ONOS logs were polluted by this group exist error. The network was stable, but having a lot of error in the ONOS logs is not good, above all if you have alarm connected to it. And basically what was happening was that ONOS was trying to install groups that were already existing in the switch. At the beginning, we were thinking that was a bug in ONOS, but then we were able to demonstrate that actually there was a bug in the OpenFlow agent that was truncating the stats exceeding the 60K bytes limit. And ONOS believed that this group were not existing and tried to install again. Lesson 2, if you change something as scale, something will break or you will notice a performance degradation. We want to reach higher scale because the requirements keep changing. And each time we want to scale more, we need to assess the reliability of the platform. But we found that on certain scale, if we reboot a switch, actually some DNF we're rebooting, taking down the services. And this is not good. As I said, the requirements keep changing, but when you start playing at scale, everything will count. And it's not a simple problem. It is a multidimensional problem. In this case, in order to accommodate more customers, we had to scale also the number of VNF. That was not a problem at the beginning, but at this scale was a problem. And sometimes you have to rethink completely your approach, and maybe you have to come up with an original solution. In this case, in order to solve the issue, we had to create a phase recovery of the switch. Second incident, we have the host discovery that was delayed during the network startup when at a certain scale. In particular, we found that reducing the neighbor advertisement interval and scaling the number of customers, the single thread that we were using in the host location tracker in ONOS was not more enough. And in this case, the issue was solved quickly, but we have to change our model for a multi-thread executor. Lesson 3, use the framework wisely. In particular, use the distributed primitives and the threads wisely. In this case, we had that if we have a lot of customers starting all together, the DHCP packet processing is very slow in ONOS. And we had a timeout in the DHCP client, exponential backoff, and time to set up the network that was very huge. And looking at the DHCP relay application, we found that there was a semaphore serializing all the hatches, counter implemented with a consistent map, which is not good for a counter. And also, we were not using the right trading model. In this case, using the appropriate trading model, removed the semaphore, implemented the counter in a different way, not with a consistent map, solved the issue. Similar to this, we found that during the creation of cross-connect service, we had timeout. In this case, there was a wrong usage of consistent map and Java code that was not optimized. Lesson 4, know your tools very well, because sometimes it's not just your code that fails, but can be also other code. In this case, we had that the cluster service was suspended by the Java garbage collector algorithm. This can happen if you are not using the right GC algorithm. In particular, we found that in the deployments, we were not using the G1 GC that is meant to be low latency. And what happened? When the GC starts, it frees all the threads. But this means that there is no liveness inside in that instance. And if this happens in parallel in two instances, this can take down the cluster. Similarly, also the logs can create problems. Yes, also the logs. Even if the logs are important, if you have not an appropriate level or the logs is too verbose in your application, this can potentially block the threads. And also the profiler can be a bad friend. The profiler can help you identify memory leak. But if you start taking snapshot, this will freeze the threads again and potentially can kill a node. Last lesson, have always a plan B. With this, I mean, it is important to have a continuous monitoring, detect fast, don't wait for the meltdown, but if you have the chance, kill gracefully. For example, in ONOS, we can take down an instance. We don't need to wait for the entire meltdown if we notice that there are problems. And you can notice this if you have alarm, if you are doing a continuous monitoring. And it's important to have a fine-grained recovery, a mechanism to clean the wrong data. The last two slides, there are links on how to get involved with ONF. There is a link at ONF Connect that was our last event, was held 2 weeks ago in Santa Clara. How to get involved with the openEDGE project, Volta community, Stratum community, Trellis community, SEBA community, or DTN community. And done. Thank you for your attention.
Any questions from the audience?
Yes. Thank you. So you mentioned you came upon some issues with when you started testing hardware, software. How many hardware platforms did you develop on?
How many?
How many different types of hardware platforms did you use?
I mean, where? For the switch or server?
Let's say for the Stratum.
OK. So for Stratum, actually, we don't have, how to say, a production-ready code, firstly. There we have support for different platforms, as I said, regarding the flexible pipeline Tofino chipset and Tomahawk ASICs for the fixed pipeline. And for the vendor support, we have support from EdgeCore, Dell, Inventec, QCT, and I think also Stardust.
And you have the different models for each chipset?
No, the models are, I mean, the chipset is the same.
Right, right. So you keep various boxes during your development and test your code on.
Yeah, we have for Stratum, we have, for example, the test vector platform that is meant for Stratum. So we run this test vector against the box. In this way, we can also qualify the box with the current feature that we have, of course.
OK. Thank you.
OK, if no other questions, thank you, Luigi.